This dude is ugly. Hey, to really see and understand what you have on your hands right here, it would be a good idea to factor this fool. So that's what I'm going to do first. So I'm going to factor him. We're going to get x plus 3 and x plus 4. Because those 3 and 4 multiplies to give me 12. They add to give me 7. So that one's rewritten. Now you can see that all our denominators are almost the same. Yeah. So let's make them all the same. So that would be x plus 3 not plus 3. Plus 4 on top of the first one. So now we have x plus 3, x plus 4. Okay, after that guy, this guy stays the same. Dang, a lot of stuff to write. I don't like writing all of this.
It's trash.
Okay. I hate writing. Gosh. Okay, this one, I'm going to go 3 times x plus 3 because that's what I have to multiply to the bottom so that it has the same denominator as the others. Now, the cool part about that, when you find common denominators, now you can eliminate all these fractions. What you do is, technically, you're multiplying everything by the denominator, and they will all get eliminated. So, I'm not going to write it all, but I'm just going to write what we have left over when we multiply everything by the denominator. We have x plus 4 plus y, and on the other side, we have 3x plus 3. And so we have y equals 2x minus 1. Does everybody see how I got it?
Yeah.
What is it?
Very fascinating, isn't it? It's just a linear equation, okay? But it's actually not that simple, okay? See, if I graph at the -1, I go up 2, 1, 2, right 1. So I have a decimal there, or a point there, a point there. So this is our line. It's a linear equation. Everybody's cool with it? Everybody's cool? Yeah. Oh, dang. Okay, so I done messed up. Okay, hold on. I didn't distribute right. This is supposed to be a 9 because 3 times x is 3x and 3 times 3 is 9. Okay, cool. So now I have y by himself. I'm going to move this x over to the other side so I get 2x. I'm going to move this constant over to the other side so I get 5. Is that what's on there? Yeah, okay, cool. I want to make sure I didn't make a mistake again. So we go to 5, we draw our point, and then we go up 2, right 1, up 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Okay, so we get our equation right here, or our line. It's kind of sloppy. Sorry about that. I didn't hit all the points, but I wanna make a point here. There should be holes in this graph. There's holes in this graph at 2 locations. Because if I go back to my original equation, am I allowed to plug in a -3? No. So we should have a hole right there at -3. So I'm going to go over to -3 and go boom and put a hole right here. We should have a hole. Just rip that paper. Okay, and then also -4, right? Because that would make this original equation undefined. So also at -4, we should have a hole. So I'm going to put a hole right here. Boom. Now that happens instead of an asymptote. There's not an asymptote there. That happens because we're able to cancel out the factors or because we did our little manipulation right here. Okay? Is everybody cool? Everybody what? Yeah? Okay, cool. So that's how you graph it. Now, finding the X and Y intercepts, since my graph looks pretty accurate, you can look at it like that and just look at the graph, or, for review. You set y equal to 0 for your x-intercept. For the y-intercept, you set x equal to 0. Okay, so it would be x, comma 0 for that point, and this would be 0, comma y for that point. So you just have to plug in 0 for the y and solve it to get your x-intercept. Plug in 0 for the x to get your y-intercept. And you could do it with this guy right here. He's more simple anyways. He doesn't look as hideous. Okay, the other things that I think this question asks you to do is to get the y alone, solve for y, and then solve for x, right? Is that it? I think you guys are good on that because this is a linear equation.